All right, we're going to start over here with none other than Team Havoc. Unless Matt wants to jump up here first. Okay. So we have Team Havoc, and I'm going to give the mic to Andy. They've been a part of their own chase group as well as part of Midwest Mezzo here for the last year and a half. So I'll let Andy tell a little bit about Team Havoc.
Hey, how's everyone doing tonight? Getting hit for tonight, Storm Chasers. This is my partner, Jeff Allen, our other partner, could not make it tonight, but he's here in spirit. Yeah, myself, I started storm chasing when I was about 13 years old. I did it for a couple of years with my cousin, and just kind of quit doing it. And I recently got back into it last year. So last year was our first year starting the team up. And it's been fun ever since. I mean, meeting all these guys and being part of this great group right here, there's nothing like it. So.
I'm Jeff Smith, I'm a storm chaser out of Northeast Kansas. Been storm chasing for quite some time. I served 18 years law enforcement. Then past 8 years working in medical services. Was chasing all through my law enforcement career. In the last couple of years, kind of got into the whole social media live streaming thing. Got partnered up with this group here, and we formed Midwest Mezzo, and we've got some great things coming down the pipe that I'm sure Matt here is going to talk about. So glad to see everybody here tonight.
Hi, I'm Matt Jones with 417 Storm Chase. This is Josh. This is my chase partner. We cover, and my boss, yes. It makes it great. We cover pretty much Kansas City South and Oklahoma to Tennessee, so all the suburbs, right? I've been on web and music my whole life. Really just kind of got into the streaming chasing lately. And then as we continued on with that, then we kind of started the Midwest Mezzo. And so in that, I built all of our ground probes for our research. That's kind of a wiring nerd, and so that's what I did.
My name is Josh. Like I said, I'm with Matt, 417 Storm Chasers. So some of our projects Matt's talking about is the ground probes. So I'm sure you guys have seen, like, reed shoots them into the tornadoes and stuff like that. We're not that advanced yet, but we've got a lot of different makes and models so far. Matt's really designed a lot of them. It's really cool. One of them was specifically on this drone that's over on the car that goes to the bottom of it. That is a sacrificial drone that we can fly into a storm and try to get some readings off it. So a lot of really good things that we're working on. Big trial period this year on everybody's got new equipment, everyone's got new streaming stuff, new subscriptions to different streaming softwares and radars and stuff like that. So we're all testing out new stuff this year, and it's been really fun to trial and error, and everyone gets mad at this one thing, it helps the other one try to figure out this one. So just lots of really cool things, great to work as a team. It's been way more fun with more people all together because we all kind of bounce ideas off each other, and someone else will take a picture from that side of the storm, and someone will be over there, and someone will see this on the radar, and it's just a lot of good camaraderie, and it's really fun to be in this group. So
I'm kind of a loner here. Anyway, my name's Mark. Everybody, Mark on Facebook. I'm out of Jamestown, Missouri. I don't know where that's at. Little video of Dinky Town, right north of Kansas City. I cover all of Missouri, out of another states. I started chase about 20 years ago. Just me, myself, and I. So if I grow up, that's it. Like what you see. So, anyway, that's me.
I'm Levin Schropp.
part of the Nader Boys with my brother Isaac. We started this 8 or 10 years ago, just off a whim. We were always interested in the storms and stuff, so we kind of went out on our own. Isaac probably talked about it when we met up with Subby a couple years back, and then the rest of the gang here. I moved down to the Springfield area, so I kind of helped cover down there with them, as well as Isaac is up here locally still, so we're just a brother team, and then we added Derek and Luke, and so Luke's really cool. He brings the snacks for us, so we always gotta have snacks, so right? There we go. Yeah, snacks. So here's my brother Isaac.
So he basically said what I was going to say. I'm up here in Western Missouri area, part of the Nader Boys, and also part of the Midwest Metro Project. When I went in and talked to Subby at the park store, I never thought this would be where we're at right now. But it's been fun every step of the way. Derek, like he said, we added last year. Luke's kind of been with us. He doesn't make it out a whole lot. He doesn't see a whole lot of him, mainly CB or Levy on the computer screen, but that's kind of all I got.
My name is Havoc and I'm from Rescue 136. We're a concept that started about 20 years ago, back in 2000, 20 plus years ago, back in 2001. And basically we're just out there in rural areas to try to be first boots on the ground in the times of disaster. We come from South Texas. We just basically came here to Missouri. We just opened an office in the last week or two in St. Joseph. And we are also a state CERT team, and we are also a Northwest Missouri Medical Reserve Corps. And we're in Northwest Missouri.
Awesome. So give these guys a hand for showing up tonight. So one important thing that I have to stress, we see this on the emergency management side that we're going to get to here in just a second, but is networking. Networking on, say, occasions like we have tonight. Most of these guys did not know each other, except, with Midwest Mezzo, we kind of come together, but networking with other emergency management offices across West Central Missouri, networking with storm chasers, our primary goal is to be able to save lives. That's why we do it. We do have, of course, we have a hobby, we have a passion for the weather, we want to get that good photo, that good video, but more importantly, the reason we started Midwest Mezzo was from a research perspective so that we can get in the hands of the professional from the National Weather Service, from the Storm Prediction Center, and get in their hands real-time data so that if we can get a warning out 5 minutes before they normally would, that could save a life. And that proved right here in Henry County last year on May 19th. PJ was not able to make it tonight, but we went down to Springfield to tell her story, and I had put it on our page, but she was watching my stream. She was about ready to go to bed. She was sitting in the chair, watching the stream on her TV. She decided that she better go take cover because I mentioned it was coming toward her area in Racket, Tightwad area. She went, she grabbed her boyfriend and her dog, they went down the stairs. About 20 minutes later, she came back upstairs and there was a 1x6 that had blown through the side of the house into the chair that she was on. This happened before the tornado warning was issued for her area. Now that's not just tooting my horn, that's tooting the horn of all of these guys that go out, they try to get the information so that they can get those warnings out to people quicker. So one more hand for these guys, please. So one big aspect also is our emergency managers across the state. So I do know that we have a few here tonight, if you are part of emergency management, will you raise your hand, please? We got Mark back in the back. Thank you. Thank you for that, guys. So this is also something that we take great pride in here in Henry County. We have our new intern, Caitlin. She's sitting over there in a pink shirt. I think this is a great learning example of what emergency management can and should do in every single county. And what I'm proud to say that we work together very, very closely with Pettis County, who is here tonight, with Johnson County in Wartburg, of course. They're here tonight. We work together so well. And that's, again, that's part of the networking that we have to do in order to save lives. So we're going to go ahead and get started, but I need a volunteer. Let me think here. You know I'm not on. Let's see here. Okay, who's good at games? Oh, hell. You're good at games? You think you can win a game tonight? All right, come on up. Come on up. What's your name? Henry. All right, Henry. I got a really simple game for you to try. Come on over here. Now, I have got a container of water with a small dish down at the bottom of it. The only thing Henry has to do is to take a quarter. He gets 4 tries. Take a quarter, he can't touch the water, and he has to drop it, and this quarter has to land in that big old cup down at the bottom of that jar. You think you can do it? All right. Here comes try number 1. There's 1. Hey, got a hand? You get 1. 2. There's 2. Oh, it didn't quite make it. All right, try one more. This is your last one. Are you ready? You think you can do it? All right, try it. All right, how about a hand? Good job. That was you actually won the game. You did really, really well. He made 75% of the quarters that he dropped into that big dish here. Now that's a pretty simple game. Most people would think you'd be able to get all 4 quarters in there. But here is what we have going on. Up above us at 18,000 feet, we have a river of air above us. It is just like liquid. It's like fluid. Those quarters represent the storm systems. Now, there's no telling how that water is going to react to that quarter. He was 75% correct. That's what we do as forecasters. We take a storm, we take a look at that river of air above us, and we have to decide where that storm is going to go. Now, I get paid for that, in which if I'm 50% right, I still get a paycheck. That's awesome about what I do for a living. He just made 75%. So, this is why we study atmospheric science, so that we can learn more about the water or the river of air above us and how it acts towards a storm. So if Derek can shut off the light for me, that way you guys can see the screen. So Severe Storm Seminar Radar Technology, brought to you by Henry County Emergency Management, Subby, Weather Talk, and all the fine storm chasers here tonight. So we're going to start with Basic Science 101, cloud formation. How do clouds form? Now obviously you have air that rises, the temperature gets cooler as the altitude increases. That causes water vapor to condense, and then you actually have drops of water clinging to dust particles in the air, and you have a cloud. Very, very simple. We all learned this in 2nd grade. There's many types of clouds. We've got the highest cloud out there is cirrus clouds. Now, if you know the answer, just blurt it out here. What is cirrus cloud made of? Say it loud. Ice. Ice crystals. 100% ice crystals. Cirrus cloud, the highest clouds out there. We are going to be talking today about that big guy over there on the right. That's a cumulonimbus cloud. There are 4 types of thunderstorms: single cell, multi-cell cluster, squall line, and a supercell. A multi-cell cluster is a thunderstorm that consists of just one ordinary cell that transitions through the life cycle and dissipates without additional new cell formation. But they often form in clusters with numerous cells in various stages of development merging together. A great example is the training of cells, where one dissipates, another one's right behind it. They keep going over the same area time and time again. A squall line. Now, squall line is the #1 type of thunderstorm we get here in west central Missouri. We don't get those big photogenic supercells that they have out in Oklahoma, Kansas, and up in Wyoming and Colorado. Now, thunderstorms will form in a line that can extend laterally for hundreds of miles. Now, these squall lines can persist for many hours, produce damaging winds and hail. They feed on the warm, moist air ahead of them. They are the most common here in west central Missouri. They can produce short-lived spit-up tornadoes, similar to what we had in the KC metro area on Friday night. They can produce large hail, strong straight-line winds. Long-lived, strong squall lines are called derechos, Spanish for straight, and they can cause considerable widespread wind damage. And several years ago, they had a derecho that was up in Iowa near Cedar Rapids that caused over $150 million in damage. This is an example of a squall line. And again, this is primarily what we get here in west central Missouri. A supercell thunderstorm. Now, those are the real picture-worthy mothership-looking cells that you see a lot on social media. They're a special kind of single-cell thunderstorm that can persist for many hours. They are responsible for nearly all of the significant tornadoes produced in the USA, and for most of the hailstones larger than golf balls. They can have updraft winds over 100 miles per hour and outflow winds on the backside over 100 miles an hour. So here is kind of a depiction of what a supercell looks like. And of course, you have a rain-free base. That's on the left side of that picture. You have a flanking line, and that is where the supercell is drawing in warm, moist air, and you have to have wind shear. You see how that entire storm is tilted just a little bit to the right? That is caused by wind shear. That is a component you have to have for severe thunderstorm, and we'll get to that here in a minute. Now, I don't know if my little pointer works. I'm going to see. Hey, it does. So this right here, this is what a lot of storm chasers look for in the spring as they're going toward a supercell. What happens, those clouds go up and so explosive, they get so high that they're almost to the troposphere, and they cannot go any higher. So if you can't go any further up, what do? You go out. And that is what creates this anvil-looking cloud up here. The clouds went as high as they could go at 80,000 feet, and they started to spread out. Sometimes these cells are so powerful that they pretty much blow away the rules of Mother Nature, and they shoot up even further. And that's called an overshooting top. If a storm chaser sees a cell out in front of them that has an overshooting top, I guarantee you we would have chaser convergence on that cell because every storm chaser is going to be chasing after the overshooting top. And then, of course, we have a rotating wall cloud, and then we have a funnel cloud, and when it touches the ground, it is therefore a tornado. Now, you have this strong updraft that's going up through the main part of the supercell. What comes up has to come down. This is the downdraft part of the cell, and of course that's where you're going to find all the heavy rain. That's when you're going to find the hail as well. We have a rear flank downdraft, and again, this is where you have this warm, moist air, sometimes up to 100 miles an hour heading into that supercell. And then, of course, you have also a inflow tail that's drawn in warm, moist air from this side. And it looks exactly like it's called. It looks like a tail. Matter of fact, 417 Chaser Josh on Friday night down near the show captured on drone a nice inflow tail going into the parent storm. What does it take to be classified as a severe storm? Well, first off, you can have winds 58 miles per hour or greater, or you can have 1-inch hail, which is the size of quarters, and you have the presence of a tornado. That is what makes a storm severe. Now, if Derek is available, if you could flip on the back light, not the front light, just the back light, so we can have a little bit of visual. So, hail size comparison is very, very important that if you call in a report to the National Weather Service, it's very, very important to let them know what size of hail that is falling at your location. But if you contact them, say through X or through Facebook, and you said, hey, we got hail down here at Tightwad the size of rocks. Well, what size of rock are we talking about? You'd be amazed how many reports the National Weather Service gets with that. And so we have kind of a common terminology that we like to use when we report hail. You have pea-size, quarter-inch, mothball, half-inch, pinch-size, three-quarter, nickel, 7/8, and then we get to the severe size. Quarter, 1-inch, golf ball, 1.75, hit A, 2-inch, tennis ball, 2.5, baseball, 2.75, softball, 4, grapefruit, 4.5, and thanks to good old Texas 3 years ago, we now have a new common term for 6-inch hail, and that is DVD size hail. And they had 3 hailstorms in a matter of 2 weeks that produced DVD size hailstone. The largest hailstone ever to fall, 7.87 inches in diameter, weighing 2 pounds, in Vivian, South Dakota. That was in 2010. Now, in order for the updraft of that supercell to be able to suspend a hailstone the size of a softball, it takes 90 mile per hour winds from the ground up into the center of that updraft of that thunderstorm. In order for this record size hailstone to be suspended in a supercell, it took over 160 mile per hour winds from the ground straight up into the supercell to keep that suspended up above our heads. That's incredible power. We will likely never see a hailstone bigger than that. Tornado genesis. We're going to talk a little bit about tornadoes. We took a look at a supercell. Now, there's a couple new terms here that I wanted to go over. Of course, we have our flanking line that is going to be basically a rain-free base underneath. You are actually going to see the overshooting top. You're going to get a shelf cloud. Now, many people call into the National Weather Service when they see a shelf cloud move in. That is not part of tornado genesis. Majority of roll clouds and shelf clouds are in severe thunderstorm warning, not associated with tornadoes. Now, this term right here, man-made clouds. If you guys have ever noticed those, they look like cotton balls hanging from the clouds. Those are man-made, and the reason why it is out in front is because it is produced by rain-cooled air that instantly sinks. So that's what gives it that cotton ball looking shape that can absolutely picture-worthy. They're beautiful, one of my favorite clouds. If you see man-made clouds, you pretty much rest assured that that cell has hail in it somewhere, because you have to cool off the air so quickly in order to form that the only way to do that is if there was hail going through those clouds. If we're looking at a radar depiction, that same photo that we looked at, this is exactly what we look for as storm chasers or social media atmospheric sciences. You have your forward flank downdraft, your rear flank downdraft, and this right here is kind of like a cold front. It's produced by rain-cooled air. You have a strong inflow of warm, moist air that gets cold. When I talk to kids in school, I refer a supercell almost like having a set of human lungs. They breathe in all of that warm, moist air, and they get really, really big and strong, and then eventually they have to let it all out. And that is what you see on the backside, and sometimes those winds can be over 100 miles an hour as well. A wall cloud. So, and again, 417 Chaser, Team Havoc, I think Nader Boy, they were all on a cell that had a developing wall cloud down in the Neo show. It's basically a lowering of the cloud base, but it has to rotate. So many invalid reports come into the National Weather Service, they see a wall cloud. The first question that the National Weather Service is going to ask, is it rotating? Well, I can't tell. Well, you can't call it a wall cloud unless you see it rotating from left to right. Those kind of clouds that are not rotating is what we call scud clouds, or scary looking clouds. And they can be confused for a wall cloud many times. And a funnel cloud, obviously, the name speaks for itself. On the bottom side of that wall cloud, you get a vortice that begins to extend down. Now, that's not a tornado right now. That is a funnel cloud. It is not a tornado until it actually hits the ground. You see a condensed funnel from the ground to the wall cloud, such as that. Now, this is a short 3-minute clip. I know all of us storm chasers, we know the story, but back a few years ago in El Reno, we lost 3 great storm chasers, researchers, one in kind of the head of the group with Tim Samaras. And this is a short, about a 3-minute clip of tornado genesis as that team was out filming and trying to get research for the National Weather Service. actually Tim and his son, along with another researcher from their team, got actually in the wrong place at the wrong time with the El Nino tornado. The El Nino tornado had a record width of 2.6 miles wide, with wind speeds of 295 miles per hour. A lot of research was gathered by Tim Samaritan and his team. Okay, so a couple years ago, me and actually it was when me and Matt Jones from 417 first met each other, and we was at the Storm Chaser National Convention up in Kansas City, Kansas, and that was the first time ever that a research team had been able to fly a drone inside of a tornado to take measurements, take pictures, and take video. Now they tried and failed many different times because a little old drone just doesn't have the power, and the batteries would run out before that drone even made it halfway toward inside that tornado. So they came up with a solution. They went with a larger airplane drone with a set of claws on the bottom that held a 4-blade copter drone. And they were able to get close enough to the tornado to allow that drone, the copter drone, to be dropped, and they had enough battery juice to be able to get into that tornado. So here we are going to have, thank you. This is called the Otis Project.
The Otis Project. This is a little bit different video than what we've seen back at the Storm Summit. And at that time, what was so cool about that video was that drone got to the very top of the cone, and they tilted their high definition camera straight down, and it was clear as day all the way down to the ground. It was absolutely mesmerizing. You notice all of the dirt, debris on the ground. All of the dirt debris going over the roofs of these barns and the houses. the whole time you're taking this video, it is also taking measurements of barometric pressure, wind speeds, temperature, dew point, everything that we are trying to do at Midwest Mezzo to try to get as much information to the professionals as we can. That's awesome. So, I had a lot of questions, especially when we get to the school-age kids, on how fast does the wind have to be in order to lift the car up and throw it miles in a tornado. And there's no good answer to that, because what a lot of people don't realize is that the basic science of getting an airplane off the ground also is used in weather. We call this the Brunelli principle. He was an 18th century mathematician, and he said that faster that the air or fluid, so to speak, the lower the pressure it becomes. Faster air over an object will cause it to lift due to pressure differences. Planes' wings tilted will cause the air under the wind to lift the plane the faster it goes. The difference in pressure causes a tornado to have extreme low pressure, kind of like a vacuum, in the center, and allows the lifting of cars, windows, blows out due to the pressure changes, extreme wind. Now, if Derek is still around, if you can flip on the light for a second. Awesome. So, I'm going to put the mic down. I'll try to talk louder. A great example of the Brunelli principle, we can even use just a common roll of toilet paper. Now, I can blow underneath this toilet paper, and it's going to lift, just like everybody expects. But you can also blow over the top of the toilet paper and have it lift. That is Brunelli principle. Now, what happens if you add even more wind to the top? It will continue to lift even faster. Let's try it on a leaf blower. Now, Dollar General store toilet paper, people don't buy it. So if I add a little wind to it, if you add a bunch of wind to it, and that is Brunelli principle. That's the ability of wind going over an object to be able to lift things. So if you might only have 120 mile an hour wind going over a car, can develop enough lift to completely lift that car up and throw it. So it doesn't take an EF4 or an EF5 to lift a car and throw it. That's the reason why if you see a tornado when you're in the car, you need to get out of the car, lay flat in a ditch. Because what happens, all the debris will go over you. If you stay in a car, it could be lifted by very nominal winds. It doesn't take a huge tornado to lift a vehicle. She's an intern, give her a little slack. All right, we can get the light shut back off real quick. So, forecasting severe weather. So, there are 4 ingredients that have to be there in order for severe weather to happen. You have to have moisture, instability, lifting mechanism, and you have to have wind shear. We can find some of this through model forecasting, T-SKUs, which we'll get to here in a minute, and the Storm Prediction Center does that for us. And if we could get a hand for our Director of Henry County Emergency Management, Mark Harden. He's picking up all the toilet paper. So our first ingredient, moisture. Dew point typically needs to be right around 55 in order for severe weather to happen. Sometimes you can do it at 50 or maybe even 53 degrees. 55 is kind of that magic number. We get this moisture from the southerly winds that brings up all the moisture from the Gulf of Mexico. That's the reason why, we have extremely humid summers. We're smack dab in the middle of the cornfields and farming fields. I did a little research on what effect that being around cornfields has on the atmosphere locally. And what I did, I took a Ziploc, went out to a pasture, a field that actually had about 150 acres of corn. This was in August, and I zip tied one bag around one leaf from one plant. I left it there for an hour and I came back. There's a process called transevaporation. The plants give off this water, and this thing had nearly 2 teaspoons of water in that bag after 1 hour from one leaf, from one corn plant in the middle of 150 acres. Now multiply that by all the leaves. This is the reason we live in some of the most humid area in the U.S. You have to have instability. Now, this is basic science. When it occurs when you have, say, a parcel of air that's warmer than the air around it. It will actually lift up. Now, if it rises just above the surface and it hits warmer air and it is not warmer than the air it's going into, excuse me, it stops. That's called a cap. Now tomorrow, most of you guys are a lot of you are weather nerds like myself. We know that we have the threat for severe weather tomorrow afternoon here in West Central Missouri. The way that tomorrow's set up is different than Friday. Is that Friday was kind of a messy day. We had no cap in place. Thunderstorms fired up very easily, and we stayed kind of a messy, rainy thunderstorm all day. And I think it was really tough for any thunderstorm to have enough energy to become really strong here in West Central Missouri. Now, we had loud thunderstorms, but they weren't too severe. Tomorrow, we are going to be underneath a very strong cap. Now, imagine a pot of boiling water on the stove. You put a lid on that pot. You take it off after 10 minutes and you see this incredible rush of steam come straight up. If you don't have a lid on that pot of boiling water, you see some of the steam kind of evaporating out. It's not that big of a deal. Same thing happens just during storm season. If we have a strong cap in place and Mother Nature is able to break that cap, we can have explosive thunderstorm development. And that is likely what's going to happen tomorrow afternoon, likely up in the KC Metro, northwest Missouri, over to northeast Missouri, all the way into Illinois. So they are expecting some big time thunderstorms up there with those guys. So this is a graphic that might help explain that a little better. So in the morning, when you have this cool air, you have the sun that's warming it up, and it lives up until it's about equal temperature, and you are under a cap. It can't go up any further. And then you get to midday, and now the sun is really warming the surface, and now it's warmer than this layer from the morning. Now you start to have some clouds forming, some cumulonimbus clouds. And then by the afternoon, it completely erodes that cap, and a parcel of air can continue to rise as high as it can. You have to have a lifting mechanism or a trigger mechanism. And examples of this is a cold front, outflow boundaries, upslope, like over in the Rocky Mountains, anything that can rise air. This is what lift looks like on Friday and what lift is going to look like going into tomorrow afternoon. We are going to have temperatures in the mid to upper 80s. The latest guidance this afternoon about 4 o'clock is showing West Central Missouri could have highs as high as 87 degrees tomorrow afternoon. Then we get a strong cold front coming our way. As soon as that strong cold front hits that warmer air, it is actually going to cause it to rise. And that's when we're going to get that explosive thunderstorm development, especially up near that front in northwest, northeast Missouri into Illinois. And you have to have wind shear. Now, their directional wind shear is needed in height. The further up above the surface we go, the stronger the wind, more degree of change in height, the stronger the supercell. We have two types of shear that can create severe thunderstorms. We actually have directional shear, in which, this is where you have east wind, you have west wind. When they meet, you get rotation. Now we also have speed shear. That's one that people forget a lot when they're looking at some of the model data and the T-skews. Speed shear, you have close to the surface, slow, say 15, 25 mile an hour winds going to the east. And then up above, you have very fast 60, 70 mile per hour winds. That creates wind shear as well. Now this is an example of why you need wind shear. Now you remember me showing a picture of the supercell, and I said that it was angled due to wind shear. The winds are forcing that supercell to bend to allow updraft to form. If we don't have any wind shear, a storm portrayed by a garden hose shooting water straight up is going to shoot up, and it's going to come right back down, and it's going to limit the intensity of this stream. Now, if we have wind shear, if we have wind that pushes from left to right, now we have a typical supercell made from a garden hose. We have strong updraft, we have wind shear that's pushing it, allowed it to continue the intensification, and we have our downdraft, and that's where all of the rain and the hail comes in front of on the backside of that thunderstorm. Where can we find all this data at that I've been talking about? Well, first off, something I look at several times a day, and that's model data. Now, what this does, one of my favorite maps to look at is the 500 millibar chart. 500 millibar is 18,000 feet above our heads. And again, we go right back over to what Henry made 75% on. This is the jet stream, and the quarters were the storms. We have a storm right here that is going to be pushed by the jet stream at 18,000 feet above our heads. Model uses AI, it uses historical data to be able to guess to the best of its ability what is going to happen in the future. Similar to if somebody was betting whether or not Henry was going to be able to drop that quarter in that cup. It is a guess at that time. T-skews and photographs. Now we can make an entire seminar just based on this one graph. This is very, very important to the atmospheric forecasters. There's so much data that is held right here. It's confusing to probably nearly everybody out there. But what this can do is, in a nutshell, this is the height above our heads. This horizontal line is the surface. This is going to tell us the red line, the temperature, as we go up in the atmosphere. The green line is going to tell us the dew point as we go up in the atmosphere. And these little flags are going to tell us what wind direction is and speed at that height. We can take a look at that, as well as CAPE. CAPE is C-A-P-E, convective available potential energy. That's how much energy that the atmosphere has to produce strong thunderstorms. This is the hodograph. Basically, we go all the way back to probably senior year trig in high school, and you plot on an X and Y axis what the wind speeds are in height. And when you see a hodograph that is curved, that means that as you go up in the atmosphere, winds are coming from a different direction. That is a sign that you could have some very volatile weather at that point that T-skew is taken. Storm Prediction Center. What's nice about these guys, they do all the work for you. You don't have to look at any T-skew or hodograph. You can go to the Storm Prediction Center page and they highlight every day who has the best chance to see severe weather. So we look at this every day. Storm chasers look at this every day. And something that was unique about Friday was the fact that it was the first time nationally since last March 10th, that they put out a slight risk for severe thunderstorms and a moderate risk for severe thunderstorms 4 days out. When the Storm Prediction Center puts out a moderate risk for severe storms 4 days out, that's when things get serious. And that's the reason why you saw so much hype on social media. My job is to be able to let everybody know the facts of what's going on here in West Central Missouri. I do not get paid. All I do is lay the facts out. If we plan, if we prepare, and our anxiety goes down, and if we should happen to get a severe thunderstorm, or if we happen to be under a tornado warning, we'll know exactly what we need to do. How to prepare, stay informed. There are tons and tons and tons of radar software and apps out there. We have Radar Scope, WeatherWise, in which I know 417 chasers are now part of WeatherWise, in which this is a free app, guys. This is you can get it on your web browser, get it on your phone. It's free. It is top of the line. We've had Zoom meetings with the owner and creator of WeatherWise, and you can get on there and see storm footage. It has a little button you just click on while you're watching radar. You can see 417's live feed while they're out chasing right from the radar app. So fantastic tool, and it's free. That's what I love about it. Of course, you can go to the National Weather Service. They have free radar. It just doesn't have nearly all the bells and whistles. Warning apps, Storm Shield, #1. I harped on Storm Shield here over the last 5 years. It's free. It follows you. It does a great job to alert you. Weather Call. I worked with Weather Call last year for a few months trying to come up with a way. It is a paid app. It costs a little over $1 a month. But you can go sign up for Weather Call. You're going to get notified when you're under a warning, watch or advisory, and during extreme emergencies such as a tornado or say a flood emergency or 80-mile-per-hour winds, you're going to get a phone call. So if it's 2 o'clock in the morning and you're sleeping and you get under a tornado warning, you're gonna get a phone call, and it's gonna be me. And I'm gonna be telling you what you're under and what you need to do to protect yourself. So that is weather call, $15 a year. You can always go to SubbyWeatherTalk.com. It's kind of a one-stop shop. You can go there. Everything that we've talked about tonight, you can find that information there on the website. County mass communication signups. I know Henry County, we use Everbridge. We put that in when Mark and I took over with the emergency management. If you live in Henry County, you can sign up. It's a free service, and you will also be notified on your phone whether or not you are under a watch warning or an advisory. And number one, a weather radio. I'm not going to spend much time on it, but anybody that knows me know what a proponent I am for a weather radio. We have several over here that we are going to be raffling off here shortly. And a weather radio should be in every household like a smoke detector. It does save lives. It's been proven to save lives. That's what radar scope looks like. This is a paid app, in which I'm going to give you guys a chance to win it here in a minute. It's a paid app, but one of the best apps on your phone. If you're a storm chaser, if you're on the road a lot, this is very quick, fast updates. It is a paid app, but it's one of the best in the business. That's what WeatherWise looks like. You can go to your browser on your desktop or on your phone. You go to weatherwise.app and you can get WeatherWise. They do have paid plans, but the free version gives you all the bells and whistles that most people would ever want in a radar app. That is what radar app, or radar, that's what this program looks like. So it will, of course, right there, that little red dot, that's me. This is taken from a screenshot from my WeatherWise program on my computer. That is weather call. So if that is something that you might be interested in, there is a QR code there. You can take your phone out, open up your camera, you can zoom in on that QR code. It will take you right to where you can sign up for weather call. Subby Weather Talk, that's what our homepage looks like. And of course, we have tons of tabs up here on top. You can get to live feed, the video blog, weather blog, and we have about 15 more tabs underneath there. Tons of information. And of course, your local emergency management social media pages. I can't stress that enough. If you live in Henry County, you can go to Henry County Office of Emergency Management on Facebook. I know Johnson County, Pettis County, they're here tonight. They do an extremely great job updating their Facebook pages to any watches, warnings, and advisories. I do know that Johnson County utilizes a program that automatically sends warnings to social media. I know that Henry County, Pettis County, we use the same program called Simple Weather Alerts. It's automatic. The minute National Weather Service issues a warning, watch, or advisory, it will pick up and post on social media automatically. So if you're able to get on social media, make sure you follow your local emergency management page. That's an example of what is posted. And again, National Weather Service alert, it tells you what is going on. You can click on it for more information, but the minute National Weather Service issues it, it's put on social media. Tornado sirens, they are for outdoor people only. They are not meant to wake you up. That's the reason why I stress the fact that you have to have an app on your phone. You have to have multiple means to get this life-saving information. I get messages all the time where, I couldn't hear them. The siren went off, and I didn't hear them. I was sleeping. They are not meant to wake you up. They are meant for people outdoors. And another folklore about tornado sirens. They will never, ever, ever sound the sirens again for an all clear. If you hear tornado sirens while you're outside, meaning that you are in danger and to seek proper cover. Okay, I think maybe back in the 50s, they would sound them, and then you would hear them again when the all clear. But that is not the case over the last few decades. If you hear tornado sirens outside, it means you need to take cover. Multiple means: phone, weather radio, family, friends, co-workers, local TV and radio, outdoor sirens, and the internet have multiple means to get that done. We talked about radar programs. How in the world does a radar work? And that's what we're going to discuss. You have a rotating radar antenna. The closest one to us is in Pleasant Hill here in Henry County. For 417 chasers, it's going to be Springfield, Missouri at the National Weather Service. You will see a big, giant soccer ball looking dome on top of a ladder. That's what it looks like, and that is Doppler radar. It will send these signals out in wavelengths. It hits the clouds, it hits the precipitation, and depends on how much of that gets reflected back to the radar, it transforms into a picture that we typically see on a radar program in different colors. There are 4 basic radar types that we're going to cover: reflectivity, velocity, vertically integrated liquid, correlation, coefficient. It took me about 3 months to say that last one. I get so tongue-tied. Reflectivity, basically, that's all that it is. It will send these wavelengths out. It will hit that torrential rain, and a lot of that energy will be directed back to the radar. That's going to give it the bright red and pink colors. Now, if it sends a wavelength out and it's scattered and it comes back in little pieces, that's all the light rain, the greens and the yellows around the red and the pinks. Velocity radar. This is one that's very important, especially for storm chasers. What it does is sends a beam out, and it can detect whether or not the winds are going toward the radar or away from the radar. They depict this by the cool colors, the greens, the whites, the blues. Those colors mean that the winds are coming toward the radar site in Pleasant Hill. The reds or the oranges, the warm colors, are going away from the radar. What we look as we're looking at radar, we're looking in that thunderstorm for a very, very small couplet that has a warm color and a cold color right next to each other. That means you have wind coming from 2 different directions, from the radar, away from the radar, and that's typically when we see some rotation in that cell. So this was a model, May 21st, 2024, and I use this date a lot because it shows you the oddness of severe thunderstorms and tornadoes. We had a line of storms all the way up near Chillicothe, Missouri, stretched all the way down into west central Missouri, down into southeast Kansas. This is what the line looked like on radar, and this was at about 3:25 in the afternoon. This is your velocity radar. We see Calhoun, Missouri on 52 highway. I was actually watching this, and I was live at this time, in which I noticed that we had the warm colors and the cool color right next to each other. Now sometimes that means just kind of broad rotation. It doesn't, and one thing that I have to stress is that broad rotation, you have to have some sort of rotation in a mesocyclone to get strong winds, to get a chance for hail, and a chance for tornadoes. But not every rotation means that there's going to be a tornado. It could be symbolizing that there could be a hail core right there. But we had no hail, and we had a strong circulation working its way down 52 Highway. I called my boss, Mr. Mark Harden, sitting over there. And I said, man, there's no warning on this thing, but I'm telling you, you better be careful, because he was at home at the time. Notice on the picture on the left, we have 3 buildings. 1, 2, and 3. And 40 seconds later, we have 2 buildings. 1 and 3. 2 and the contents were nowhere to be found. That's how fast that one of those spin-up tornadoes along a line of storms can happen. That same line of storms wreaked havoc just north of Clinton. We had trees down, there was some damage. This, I believe, Mark, this was what was inside door number 2, wasn't it? So all that was left really was the golf cart. So, need a volunteer. Somebody that had an Android phone. Who had an Android phone? Let's see, I see a hand raised up back there. Come on up here. All right, he has a chance to win a fabulous prize. Are you ready? All right. You're looking at radar at 3:30 in the afternoon. You turn it over to velocity radar, and you happen to see this. Would you issue a tornado warning if you work for the National Weather Service? Remember, their broad rotation sometimes does not mean there could be a tornado, and then sometimes there's small couplets that could signal there could be a tornado. Would you issue a tornado warning? You would? Okay, show of hands. Who agrees with him? Okay. Who thinks you should not issue a tornado warning? Raise your hand. The answer is an EF2 tornado. This was the actual velocity signature for an EF2 tornado. So you are right. And what you win what's your name? All right. This young man just won a year's subscription to Radar Scope. All right. Who has an Apple phone? Who wants to be a volunteer? You do? You raise your hand? Sure. Oh, cool. Come on. Okay, you ready? Here's your test. Would you issue a tornado warning on that? You would? All right, who agrees with this young man? A tornado warning should be issued. We have a couple who think there should not be a tornado warning. Okay, there should not be a tornado warning. This is actually a very broad circulation. It's something we're going to keep a very close eye on for any strengthening, but that is not worthy of a tornado warning. But we do give away I Try trophies. You get a year's subscription as well. All right, next, radar. We are going to be looking at the VIL, vertically integrated liquid. It's a mouthful, but it's very, very simple and it's very useful. We use this to detect hail cores. What this radar does, it measures the mass of the rain particles or the hail particles. that bigger, heavier the mass, the more gray and white the returns are to radar. We are able to move over to this radar view to detect the strong hail cores, and that's what the National Weather Service uses to issue severe thunderstorm warnings for hail, is the vertically integrated liquid radar. So, we're going to talk a little bit about that big old long word, coalition coefficient. Now, when I use my radar program, I typically set it up for 2 screens or 4 screens. This is your reflectivity. This is our velocity radar that we just talked about. This is this is a little bit different. Now, I actually like to look at this also kind of like the vertically integrated liquid. It also measures mass of particles. And then we have good old correlation coefficient. This looks very, very confusing. Easiest way that I can put it to you guys, if you have a clear jar like this full of marbles, and you throw in, say, a couple of Tootsie Rolls, maybe a sucker, maybe a jawbreaker, maybe a fun-sized Snicker, and mix it around in with those marbles, that correlation coefficient radar, its job is to detect the different size particles in the clouds. What does that do for us? That can detect a signature for debris called the debris ball. So when we see velocity radar that looks like there is a very, very strong coupling, you got really deep blue, you have really dark red, you have the cool and the hot colors together, that looks like that could have a tornado. We use confirmation going over to correlation coefficient. All these reds are all raindrops or marbles, so to speak. This little ball right here are the Tootsie Rolls and the fun-sized Snicker bars. That's what it is picking out right there. That is a debris ball. At that point in time, if the National Weather Service sees that, they are issuing a tornado warning for a tornado likely on the ground picking up debris. It is picking up pieces of wood, shingles, pieces of trees, and that is what is picking up the different sizes of something that is not like rain or hail up above us. That's what correlation coefficient is, a very important part of tracking storms, especially for the storm chaser. So the National Weather Service offers storm spotter classes yearly, in which we are going to be having one that's going to be coming a little bit late. It's going to be next month for the first responders. It's basically just on storm spotting. It is put on by the National Weather Service. We'll make sure to announce the dates on that next month. You can also, if you don't live close here, you can go to subbyweathertalk.com. I have the new 2026 Storm Spotter class available on YouTube. You can click, take the class. It takes about 45 minutes, and you can print off your certificate to be a storm spotter for 2026. So what we are going to do, we are getting ready to hear from Gary Lezak. It looks like it's 7:40. We are going to take a 5-minute break, let you guys go to the restroom, and we are going to do some drawings up here, so make sure you have your tickets out. We're going to do that, and then we're going to come back and listen to what Gary has to say here in about 5 minutes. Remember, bathrooms right through the double door there, and help yourself to whatever we got left of cookies over here.
It was some horrible routes.
Okay, that top, you got very small cabin. Another is on the T view where the red line is. Okay? The parcel of air starts at the surface. It's that 30-degree, say 50 degrees, that's the surface. And then it's lifting and it's able to go up. Okay, because it's lower than the aircraft. If you see that red line shooting to the right, at above like 1,500 feet, 2,000 feet, that's the cap. You know, warmer than itself in the camera.
All right, if everybody want to get their tickets out, we're going to do some drawing here. Yeah, you come over and say hi. You want to give me your own message when you grow up. All right, high five. Good job. All right, here we go, guys. You want to read out the numbers? Yeah, if anybody is back there by the light, can you flip those light switches on for us? To turn them all on. Thank you. We're gonna do a few weather radios right now, so get your ticket.
101009.
Excellent. You are welcome. Subby, weather talk at
041.
041, last three digits. Hey, we got one down there. Go for it. 417 Shaker hat.
139.
139.
I'm meteorologist Gary Lezak with Weather 2020. Subby, thank you for inviting me. Maybe next year I can be there in person. There's a lot going on. Oh my goodness, this weather pattern. There's a river of air above us that is cycling regularly, and we have cracked the code. The pattern cycles, and we are able to make prediction weeks to months in advance accurately. That will help you in your weather-sensitive business, on your farm, corn, soybeans, whatever you're wondering about weather-wise. The tool that I'm going to share with you in just a few minutes, the LRC model, is available. And I'll try to do a live demo. Let's get started and show you what's going on. We'll go right here from the beginning. You can see a Weather 2020 vision into the new year. This year has been a fascinating first couple months, and we have cracked the code, as I said, of this crazy weather pattern. And it's called the LRC. It was named by the bloggers. I'm sure Subby can tell you all about that back in 2002, 2003. In the last 20 years, we've been bringing this to the world. And the LRC is the centerpiece of the big atmospheric puzzle. It is a jigsaw. You've heard of El Nino, La Nina. That's called the El Nino Southern Oscillation Index. La Nina is the cooling of the tropical Pacific Ocean. El Nino is the warming of the tropical waters. All right? We are literally in a transition right now from La Nina to what next winter may actually be an El Nino. There's the MJO, the AO, the NAO. The AO is the Arctic Oscillation, another one of the fringe pieces. Look at this over here. You see this arrow? The AO dipped in late January, and that led to the Arctic blast that has been relentless and has not let up in the eastern part of the country. It goes in and out. But look, 11 weeks earlier, a similar dip. Not quite as deep, so we didn't get the Arctic blast, but very close. The pattern is cycling even at looking at these indexes. One of the key elements of what I've been discussing for 20 to 30 to 40 years now is that these anchor troughs and ridges form. And this year we have a problem in the Rockies. Colorado has been at record pace for the lowest snowpack ever from October through February. It was the lowest snowpack ever. Denver setting all kinds of warm winter records. Why? This anchor ridge. Storm systems will make it into the west. Some of them may even be strong in the Rockies. We have a couple right now coming in. But overall, they usually weaken. They're not as frequent. And this could be a problem. I'll show you what it may lead to in a minute. Then, as they go east towards Kansas and Missouri, the storm systems try to start intensifying, and then they become very impactful in this anchor trough where storm systems are more frequent and stronger. This ridge, though, is a problem for the summer. In fact, because of it, we are predicting a major heat wave, late July and early August. Now, will it be hot and dry before this time frame? Because if it is, this will really be impacting. If it's wet earlier in the season, maybe it won't be as impacting. But just know this is our forecast for a potential major heat wave. I'm about 75% confident it will happen around the first week of August. Yes, that's the hottest time of the year, but I'm not saying it's going to be near 92, 95. I'm saying it could be 102, 105, and even hotter than that over Texas. So this is something of a concern. We're in this part of the pattern right now at this moment. We're going from phase 2 into phase 1 amplification. This is what we predicted during the winter with showers, thunderstorms in the southwest, either severe weather or possible ice and snow. That's been happening in the last week or two. So we'll see what happens this spring. This could be a week or 2 week wet period, all right? And it's already happened twice this winter season. We'll see about what happens for the spring. Planting, growing, and harvest forecast, all right? If you knew, what would you do? As we go from winter into spring, knowing when to pay attention. Identifying multi-week dry spells or high-risk wet periods is what our model is able to do. Protecting planting and harvest windows. Anticipating peak severe weather periods. 90% accurate in predicting severe weather in the last 4 years. And reduce last-minute surprises. That's what we do. We are very rarely ever surprised when something's happening because we predicted it. So very interesting. So the model, this is the LRC model, and I'm going to do a live demo in a second. This is the forecast from January to June that we have had out for this entire time. And notice a little cooler through the Great Lakes area, near average to cooler than average, and everyone else warmer than average weather expected this spring. Rainfall-wise, North Dakota looks like it'll do good on moisture. Iowa could be a struggle. Missouri, Kansas could be a struggle. Let's go take a look at specifically at Missouri. Missouri, notice how it shows below average. This is 60% to 90% of average rainfall expected from April to June. You can see here, there is the precipitation forecast for the 3 months ahead of us. So could it be just enough moisture, or could be there'd be problems? Now this area is getting hit right now with lots of rain. So we'll see if it dries out again, which I expect it to. So let's do a live look at our model, all right? If you want this, Subby will tell you how to get it. Go to weather2020.com. But what we do is let's just put in Missouri. Well, let's say you want to know Brazil or Argentina. If you get the world version, you just put in Brazil. Let me put it in real quick. And Brazil, click, and then you can put the date range. Let's go from April 1st, just put a date in. You can do this yourself, to August 31st. Okay, apply and apply. Here it comes, the forecast for Brazil. Watch this. All right, it's coming up. It's calculating. I said I was going to do it live. We'll see what happens here. Come on. Oh, there it goes. Thank goodness. Here's Brazil's forecast. You can zoom in to Brazil. And wherever you zoom in Brazil, the Amazon rainforest or whatever, you'll see they're expecting that's 160% of average rainfall in this region. 230, double rainfall. And then you go to Sao Paulo, and it's only 130%. So, but look, most of Brazil expecting to be above average. It tells you how much rain is going to be, high temperatures, low temperatures, etc. So let's get back to the United States and go and do Missouri again. Okay, United States, hold on. United States. Here we go. And then you just put in Missouri. You click on Missouri. Boom, like that. And here's Missouri for the next few months ahead, all the way through August. This shows you which weeks will be what. Everything above this 100% line is a wet week. Second week of April, a wet week. Most likely drier weeks, and then a wet week at the end of April. Then a couple of dry weeks to start May. May could be a struggle. This is when we're going to watch for possible drying out. In May, yes, let's hope not. But you can see our model is predicting drier, and then a wet week in the second week of June and the first week of summer. So here's all the way through August in Missouri. See this? And then you hover over your county, and if you want to put in your county, you can. So we're going to put in like, how about Henry County? You put in Henry County, and let's do also Cass County. Henry and Cass County. Just a couple counties to pick. We can pick any county, and you push apply, and it literally will show those counties down to your county, a tool I think every one of you should have. And you can see here it shows 18.9 inches of rain between now and August in Cass County, and in Henry County 16.8 inches, and that is 80% and about 80% of average rainfall. And you come up here on these other tabs, snow and precipitation, temperature insights, year-over-year comparison, and you get your degree days. You get your heating degree days, cooling degree days, and growing degree days. So they're all in here. As you can see here, we go to the long range overview. I think it's down here at the bottom here. Here is growing degree days. Shows you how many you'll have during that entire period. So pretty interesting. So there you go. That's just a demo of our model. Somebody can tell you how to get that. I highly recommend it. And so we will work on a deal if you want a deal. All right, so thank you, everyone. Very interesting weather pattern evolving this week, next few weeks. I'm meteorologist Gary Lezak, and of course, let me know if there's any questions, and Jim can send them to me, and I will let you know what my answers are. All right, there you go. I better stop this recording. Have a good day. Have a good discussion.